Chapter 9, Advanced Array Concepts, Part 1. So our objectives for this chapter are to learn how to sort array elements using the bubble sort algorithm. The bubble sort algorithm is one of the most straightforward algorithms to learn how to code. It also tends to be pretty inefficient. My rule of thumb is that what's easier for the programmer is more difficult for the computer, and what's easier for the computer is more difficult for the programmer. We're going to learn how to sort array elements using the insertion sort algorithm. We're going to use two-dimensional arrays and other excuse me, and other multidimensional arrays. We're going to use the arrays class and the array list class. We are not going to create enumerations. It's not part of our course objectives, and so we are going to skip the enumerations section of this chapter. Certainly feel free to go through it if that interests you, but it's not something we need to do for cis163aa. So let's look at sorting. Sorting is the process of arranging a series of objects in some logical order. It's easy to think of numbers like integers in sorting because we put them in ascending or descending order, from smallest to largest or from largest to smallest. When we start sorting objects, it gets a little bit more difficult. When we're sorting employees, are we going to sort them alphabetically by name, by employee number, by salary? See, we have to make those decisions when we are looking at sorting objects, but sorting primitive types is pretty easy. Ascending order means we start with the smallest and we go to the largest, and descending order means we start with the largest and go to the smallest. So, the bubble sort is the simplest of all algorithms, and it involves comparing two values that are, and if they are out of order, then swapping those values. The swap routine requires a third variable location because we can't just say take what's in value A and put it in value B, and take what's in value B and put it in value A, because if we did that, we'd lose one of them. We need to have a temporary holding spot where we put one of our values for the moment and then get it out later. These 3 lines of code are the simple swap routine that is required whenever you want to swap values. Assume 16 is in val A and 2 is in val B. If we want to swap them, we set some variable temp equal to val A, so 16 is going to get stored in temp. Then we take the 2 out of val B and stick it in val A, and then we take the 16 out of temp and put it in val B, and then we've just effectively swapped our 2 and our 16. So the bubble sort, to perform the bubble sort, you compare pairs of items, swapping them if they are out of order. So the smallest item will bubble up to the top of the list. So you compare the first 2 and then the second 2 and then the third 2 and so on until you get to the end of the list, and then you repeat the process until you've traversed the list n-1 number of times. Here's an example. We're using 2 for loops for a equals 0, a less than sum nums.length minus 1 plus a. For b equals 0, b less than sum nums.length minus 1 plus b. If sum nums sub b is greater than sum nums sub b plus 1, we're going to swap them. And then we do that sum nums.length minus 1 number of times. Starting at 0, so actually it's sum nums.length number of times. And hang on, I'm worried we have an error. I think that this is going to cause an error, because what happens when when b is at Okay, we're fine. When b is less than sum nums.length minus 1, my concern was what happens with b plus 1? Is it going to be sum nums.length? But it's not, because we have b less than sum nums.length minus 1, so we will not get to the last, we will not get to sum nums.length. We won't have an out of bounds error, which is what I was worried about. Notice you've got a nested for loop here. You've got your outer loop, your for A loop, and your inner loop, your for B loop, because one pass through the list isn't going to get that list sorted. One pass through the list is going to get the smallest item. Hang on, let's see if we're doing largest or smallest. One pass through the list is going to get the largest item at the end, but it's not going to have all of the items sorted, and that's why we need to have a nested for loop so that we make n minus 1 or length minus 1 number of passes through the list. It's for them all to be sorted. So here's an example of using the bubble sort algorithm, and notice that they are modifying the comparisons to make variable. Int comparisons to make equals sumnums.length minus 1. For a equals 0, a less than sumnums.length minus 1 plus a. For b equals 0, b less than comparisons to make. And notice that this is being changed. At the bottom of the loop, it's highlighted, minus minus comparisons to make, because once the largest element has bubbled up to the end of the list, do we ever need to look at it again? We don't, because we know that it's already in place. It's already bubbled up to where it belongs. So we don't need to go back and compare that value again. It's a waste of time. So we're using this comparisons to make variable to make our algorithm more efficient. One of the things with programming is we never want to ask questions we already know the answers to. And this helps us avoid that problem. You can sort an array of objects in much the same way you sort primitive types, but you have to decide what your search criteria is going to be. What element of what field in the object are you going to sort on? And you have to compare that. So that's the biggest important distinction to make. The insertion sort is a sorting algorithm that enables you to look at each list element one at a time. So we're going to compare a particular value and insert it where it goes in the list. So you're going to move items down if the tested element should be inserted prior to other elements. This is similar to what you would be doing if you were sorting a group of objects manually, moving things out of the way to make room for the one that you want to put in place. Here's an example. Let's assume we have an array list, a list of numbers, an array called sumnums. It's got 90, 85, 65, 95, 75. A equals 1, while a is less than sumnums.length. Temp equals sumnums sub a. So temp is going to be equal to 85. And we're going to set b equal to a minus 1. So b is going to start at 0 this first time through the list, while b is greater than or equal to 0, and it is because we're starting at 0. And sumnums sub b is greater than temp. So sumnums sub b is 90. Is that greater than temp? Temp is 85. It is. So we set sumnums sub b plus 1 equals sumnums sub b. So we're taking we're taking that 90 and we're putting it in the place where an 85 is, and then we're subtracting 1 from b. So b becomes negative 1. So that ends our while loop. Sumnums sub b plus 1, so now we're at sumnums sub 0 equals temp. So we're taking 85 and we're putting it at the first element in the list. And plus a. So we're going to take a look at the next element in the list. This is an example of an insertion sort. I encourage you to type this up, experiment with it, give yourself a different list of items and see how it works. Hand tracing through it is really important to try to think through each line of code and see what it does. I talk you through it, but it's really helpful for you to try to do that for yourself, in addition to typing it up. If you make some typos, that's really super helpful when you're typing up your code, because then that gives you some debugging practice.